recalled from the market. So this kind of polymorphic changes is also considered under stress conditions. We need to watch this. Because drug efficacy reduces also, it is going to be impact on patient. This is different case. The latest examples are like MDSR inhibitors. Last time we conducted one international seminar there in AKN University. Nitration or the impurities may undergo nitration. Because for nitration, secondary amine is required. In this drug, there is no secondary amine directly possible. Therefore, assess the toxicity during this using this KSAR models, and we need to assess whether there is a genotoxicity or. You already know what is genotoxicity. Genotoxicity means it can alter the genes, so which is very dangerous things for human health. So both molecules we have gone through these studies. ICH-M7 class C categorization came. You can see the last results. In silico simulations we have done, it shows positive. It means these are all proven genotoxic impurities, carcinogenic impurities, which should be controlled at very low level in the drug or formulation. So this is also modern tools, we can use it. So again, while after establishing the standards, we have developed a suitable LCMS method to quantify that in ppm level. So this is the typical mass data for blank, placebo, and standard solutions, and the spider sample solution, LCMS data. So those are all different cases have presented, but while doing that characterization of the impurities, so you need to use most advanced analytical tools, so such as like liquid chromatography, PLC or HPLCs, mass spectrometry, NMR, and even modern analytical techniques like with high resolution NMR to have more accuracy in the mass up to decimal level, and powder XRD, as I mentioned, to study the polymorphic changes, and single crystal XRD for structure characterization, and LCNMR. LCNMR is also a tool where no need to isolate the compound because certain times the compounds are very precious, even mg level only you can have, at least do. But in that case, LCNMR is a direct option where we can take the NMR spectra from the chromogram itself. But here we need to use deuterated solvents, which is expensive. Nature of the impurity. Suppose if the impurity form is not UV sensitive, if we are using an UV detector, so then you won't see any peaks. But in that case, you need to use alternative detectors like chemical ionization detector, conductivity detector, or ELSD detector, evaporative light scattering detector. These are all alternative detectors to the UV detector. So then certain compounds are not coming up in UV detector, so you can use these detectors. Even there is another detector called a refractive index RI detector. So by utilizing all these detectors, you can if any compounds are missing, you can screen up in the other detectors. That is one best example, because ultimately we need to achieve 99.9% or close to 100% mass balance. Then only your method can be proved as stability indicating, meaning that all the degradation products formed are eluting in your analytical. That is what expectation is. If you use such analytical methods, that would be a starting point to develop a stable formulation. Because to develop a stable formulation or stable drug product, you need to use a proper analytical. So control measures. So develop analytical methods that can differentiate between the APA degradation, APA and degradation. See, in the case of the arcanacin, we have used an UPLC method in 14 minutes, almost 14 peaks, including drug peak, are separating. If we add bromide peak, even 15 peaks within 14 minutes or 15 minutes, each minute one peak. So this is the power of UPLC technique. So where you can use less amount of solvents, and but within peak time, 14 minutes of time, this much resolution we have achieved. So meaning ultimately more specific method means each peak should be separated there. It should not be interfered with one another. That is what the requirement for the analytical. So the validation criteria, you need to demonstrate the specificity. All degradation peaks should be separated. And mass balance, the most important thing is mass balance must be demonstrated between assay and impurities method. So when it comes to formulation, by using this degradation behavior understanding,
last phase of it. Thank you very, very much. You know, the way you were talking and the way you are presenting yourself. This is what we need. Thank you very much, and God bless you. Thank you for joining.
So, any questions that I can take, or another speaker is waiting?
Hello, sir. Thank you very much, sir. Thank you very much for your nice presentation. You have explained the degradation behavior and forced degradation studies and unknown degradation impurities also we have explained in your presentation. And even advanced analytical tools also you have explained. And during the initial release of this drug and whatever you have that shelf life, what you have explained that. And other thing is our audience got an idea that safe idea and effective medicine is more important for the humankind. And the most another important thing you have mentioned in your talk that avoid regulatory actions and consequences, or otherwise minimize. So very nice presentation, sir. Thank you very much from the nannayanewstv from the bottom of my heart. So for you, with your speech, with your talk, our students got more idea about analytical techniques and drug validation and everything. Now it is open for questions. Anyone who is having doubts, you can raise your question. Now speaker is ready to give answers to your questions. Tell your name and...
Sir, good evening, sir. I am Adnan. I am working in Grand Pharma Limited, Analytical Research Development, Hyderabad. Thank you for your good supporting. And I have two questions, sir. Actually, we are going to one drug product for filing. How many degradation conditions required for? We have 5 to 6 degradation conditions. How many degradations required, sir?
Any new drug if you develop, so there are standard degradation conditions that you can refer ICH guidelines. As I mentioned, acid base and peroxide degradations, photolytic degradation, and temperature or thermolytic also we need to come. Based on all these along with that, ICH Q1B so suggests photo degradation using stability chambers. So that degradation also we need to perform and see what are all the degradation peaks observed.
How much degradation percentage required, sir? As
per ICH, up to 20% you need to degrade. In some cases, it is not possible to degrade because of the molecule stability. So in that case, you need to show your efforts. Means you need to increase the concentration of reagents from 0.1 normal to 5 normal. Either it could be hydrochloric acid or sodium hydroxide, or if it is a peroxide, you can vary the concentration from 1% to 100%. So also you can change the reaction conditions by applying temperature and time. So at multiple stages you need to increase the stress and see until you reach the degradation of 20%. In some cases, as I mentioned, so it is not possible, but in that case you need to show your experimental to reach the 20% is suggested.
Okay, sir. Thank you, sir. Thank you, Devan sir.
Thank you, Hari.
Thank you very much. Any more questions from the audience, participants, delegates? You can raise your question. The speaker is ready to give answers to your question. Any queries? If there are no queries, Dr. Vishnu sir, we are very much thankful to you for your taking a pain like this, you are giving your talk at the midnight of American timings. Thank you very much from the bottom of my heart. And our esteemed Vice Chancellor Madam is here. And we are not able to felicitate you physically, but Sir, Madam, Sir, Vishnu Sir requested us, Sir, the father will come in the valedictory session to receive felicitation. With the permission of Honorable Vice Chancellor, may I go? Okay.
Thank you very much, Vision.
Okay, sir. Thank you very much, sir. Thank you. Now, we'll go for the next speaker presentation. We have another speaker from United States of America, Dr. Pavani. Dr. G. Pavani is who is a very good young researcher, doing very good research in the field of analytical chemistry. Now I request Robina to introduce our speaker, G. Pavani, to the audience, please.
Good morning to everyone. I am Robina, pursuing MSc Analytical Chemistry. I briefly present the biodata of Dr. Pavani Gonabattula. Dr. Pavani is a clinical and translational pharmacologist with 10 years experience in pharmacokinetics and toxicology across preclinical and clinical drug development. Former US FDA and CDC researcher with expertise in PBPK or PBPK and POPPK modeling, PK or PD analysis, and ADME or DMPK studies to inform dose selection, exposure-response relationships, and clinical translation. Adept at integrating model-informed drug development and quantitative systems approaches to bridge preclinical data with clinical outcomes, optimize therapeutic strategies through evidence-based decision making. She has completed her PhD in environmental toxicology, Texas Southern University, Texas in 2020. M.Pharma in industrial pharmacy, Kaktiya University, India in 2014. Bachelor of Pharmacy, Andhra University in India, 2010. Diploma in Pharmacy, State Board of Technical Education, India, 2005. PBPK Modeling Course, University of Florida, Florida, 2022. Graduate Certificate in Regulatory Science, UAMS, Arkansas, 2023. Dr. Pavani is a AI or LLM researcher in Innodata INC and also a pharmacokinetic modeling postdoctorate in Centers for Disease Control and Prevention, ATS, DR, and US Food and Drug Administrator, NCTR. She is also worked as a lecturer in pharmacy at Government Polytechnic College for Women and also in Dr. Reddy's Laboratories as quality control training. This is to be certified that Dr. Pavani as a PRISMA reporting and confidence December in 2023. Research collaborations in design, synthesis, and biological evolution of novel hormone-based triazole derivatives as potent. Dr. Pavani also received academic achievements in RASS John Dole Risk Assessment Endowment Award in 2023. Dr. Pavani's volunteer experience in Science Fair judged at the Science Fair in 2017, Science Fair judged at Beatrice Mace Institute Charter School in 2017 and 2018. It's been a privilege to have you here, ma'am. We are truly thankful for your gracious presence.
Thank you, Robina, for the introduction of our today's speaker from United States of America, Dr. G. Pavani Garu, who is a very good researcher. Now, Dr. G. Pavani Garu will present the presentation. Over to Pavani Garu. Madam, are you
Thank you, Rubina. Thank you, sir, for a great introduction. Good morning, everyone, all the participants, delegates, and Vice Chancellor. And I'm very honored to be here, part of this conference. Just a second, I'll share my screen.
Please.
Are you seeing my presentation, sir? Please confirm.
When you go to just your message is coming, you are presenting.
Are you seeing my PowerPoint presentation, sir?
No, madam. Madam, you click on show my screen.
Yes, sir.
No, that's not coming.
Yeah, Pawan, select the specific window. Otherwise, it will go.
You please select the specific window, madam. Your window while you are sharing.
Stop sharing and then select again.
Again, you stop this.
Yeah, let me
Stop it and come back. You share the screen, then you select on the particular window.
Yeah.
Yes, sir.
Yes, now we are able to see.
Full screen, sir. Okay.
Now it is okay, madam.
Okay, sir. Now you are saying, right?
Yes, madam. You can continue, madam. Please, madam.
Good morning, everyone. Again, this is Pavani Gunnavatula. Today I'm going to talk about advancing ecotoxicology and human health risk assessment through physiologically based modeling. My expertise is in modeling and simulation for both the clean pharmacology and toxicology, protecting human health and ecotoxicology. Today's topic, I'm going to discuss about the application of modeling and simulation, environmental health risk assessment, and presenting few case studies and summarizing the key parameters, estimations, and what is the impact of modeling and simulation for human and ecotoxicology. What is chemical risk assessment? In simple terms, understanding how pollution in our air, water, and food affects both human health and ecotoxicology. In general, for chemical risk assessment, we understand what is the hazardous chemicals, and we interpret dose exposure response, and we characterize chemical risk assessment by quantification of risk hazard quantification values. This schema shows general sources that contributes environmental contamination, mainly from home effluents, industrial wastages, livestock discharge, agriculture runoff, landfills. All these contributes to wastewater treatment plants, but still 100% wastewater treatment plants are not capable to remove all these contaminants, which further discharge into water sources, both surface water, groundwater, ultimately contaminates drinking water, which pose for most human health risk. So what is the importance of computational tools for environmental risk assessment? Chemical releases into environmental pose risk to both human and ecology by causing severe toxicology effects. Fortunately, advancements in computational tools helps to challenge these challenges, prevent these challenges by fate and transportation modeling, which predicts chemical dispersion in ecosystem like air, water, and soil, and physiologically based pharmacokinetic model, which helps to assess human exposures and predicts body burden of these chemicals exposures. These tools helps to improve our understanding and capability when such chemical incidents happen or any chemical scenario exposures. In simple terms, what is fate and transportation model helps to predict how chemicals move through the ecosystem, either in air, water, soil, sediment over the time. With this fate and model transport modeling, ecosystem. This helps in risk assessment by providing realistic exposures for PBPK modeling to predict human exposures, which further helps to human risk assessment. It also links emission scenarios to internal doses in humans and ecology. PBPK modeling. PBPK modeling is a mathematical approach to predict absorption, distribution, metabolism, excretion of chemicals within the living organisms in humans and other species as well. PBPK modeling is like a new approach methodologies which helps to predict exposures across life stages when there is a data gap for special populations like pediatrics, pregnancy and geriatrics. Such alternative methodologies are accepting across regulatory agencies to support regulatory frameworks and guidelines and to implement government policies for health and human risk assessment. PBPK modeling simply, it integrates organ tissues as a compartments using computational framework and ODE equations. It can be done by both commercial softwares and open source tools like R programming and commercial softwares like GastroPace and SimSip, and there are many other softwares. In simple terms, PBPK is a virtual body which uses computational simulation. It predicts what happens to chemicals inside you without doing any physical experimentation. Why PBPK matters in environmental risk assessment? Because it integrates external environmental exposures to internal dose metrics, which drives toxicity. It quantifies internal chemical doses for accurate human and ecological risk assessment. It translates biomonitoring data into a mechanistic understanding of exposures, reduces uncertainty and in interspecies like from animal species to human species and special populations like adults to geriatrics, children and pregnancy, and strengthens evidence-based regulatory decisions for policy making. I would like to present a case study which gives you an overview of PBPK model integrating environmental and human health risk assessment. For human health, we can predict tissue exposures from either air, water or dietary contamination. We assess the dose-response relationship and we can evaluate exposure of these environmental exposures across species and across different life stages like infants, pregnancy, elderly or any other special disease population. It supports safety assessments, biomonitoring interpretation and regulatory limit setting. Coming to ecological risk assessment modeling, we can simulate uptake, metabolism, distribution of pollutants in different species like fish, birds and mammals. We can predict bioaccumulation, trophic transfer and long-term persistence in ecosystem. We can also quantify tissue level effects of those exposures across species. It helps to inform suitable chemical management and guide environmental policies. We worked on a case study, ciprofloxacin exposure model, where we can go through the life cycle of ciprofloxacin from the time it discharges into water bodies, its sediments and exposure to fish species and further human exposure through diet. This gives you like overview the schema, the discharge of chemicals from industry through water sources, further accumulation in fish species and further uptake by humans. We do this analysis by predicting water concentrations of those contaminants and sediment concentrations and human biological uptake by integrating toxicokinetic modeling and PBPK modeling. First step, environmental fate modeling. It predicts how much chemical stays in water, moves into sediments and further breakdowns or degradation by several factors like sunlight, microbes or natural breakdown. So here we can see from the fate modeling, the exposure of chemical in water spikes at almost 1.4 microgram per liter on day 3, further declines sources and how fast it is degrading. It is simply says like a fate modeling of the chemical. And the sediment concentration here we can see it accumulates, and the peak here we can see the stable. That means it has a strong absorption but slower clearance from the sediment sources. Next step, after measuring the concentrations in water sources, we do a PBTK model of fish model. It helps to predict how much chemical entering into fish body and further where it goes. This model represents fish by using different compartments. Like I previously mentioned, PBTK model comprises different organs as a compartments interlinked by tissues and blood flow. So with this PBTK model of fish, we can predict how much concentration is fish exposing. And with this prediction, we can say the internal residual concentration highly increased after first week of exposure within 4 days, and it's gradually decreasing. We can say based on this prediction there is an acute exposure, but it gradually decreasing, which indicates chronic exposure for these species. Based on those predictions, we quantify risk coefficient by calculating measured environmental concentration and predicted no effect concentration. We will quantify based on the RQ value. If it is below 1, we say there is a risk is low. If the RQ value is above 1, we say the risk of exposure is potentially ecological risk. Based on our model prediction, we can see the RQ value initially increased more than 1, it's almost close to 30, and it gradually decreases. Again, it indicates like acute ecological risk, and later it's like a chronic toxicology effect. Next, GUTS TD model, toxicokinetic, toxicodynamic model. It gives like a predict survival probability of aquatic organisms. In this case, the fish survival probability. So based on this model prediction, we say how fast the toxicity accumulates when the internal concentration exceeds organism's tolerance, and delayed or time-dependent effect. Based on this model prediction, we can see the gut survival decreases to 0.6, showing temporary population level stress at the initial exposure, and it gradually decreasing. So it indicates there is a survival pressure on these fish population at initial level of exposure. We can again say it has a like acute toxicity. Next model, human exposure modeling. It helps us to understand humans are exposed through eating contaminated food. We calculate estimated daily intake, and we quantify hazardous by hazardous coefficient value. Based on the model prediction, if HQ value is less than 1, we say human health risk is unlikely, and if HQ value is greater than 1, we say it potentially causes toxicity to human through food consumption of contaminated fish. Here in this model, we have a EDI value which yields HQ value less than 1. That implies low consumer risk, which is like less toxic to human, but elevated ecological risk for fish species. Summary of this modeling framework, it helps to understand where the chemical goes from the time it discharges into environment. The life cycle of the chemical we can model through transport and fate modeling, and how much accumulates inside the fish species. Not only fish species, we can do modeling for any other species that exposes to these chemical incidents. In this case, the fish PBTK model, and it helps to understand whether ecosystems are at risk by doing GUTS model and quantifying RQ values. And we also predict a human risk assessment by doing EDA calculation and HQ calculation, which gives understanding of of this framework, what is the core impact of modeling and simulation? It helps to predict the exposures of any environmental pollutants before they cause damage to ecosystem. Ecosystem itself includes humans and other species as well. And efficiency of this modeling framework, it reduces the need of extensive and costly animal testing in regulatory science. As you may aware, recently UK government also approved for reducing animal studies, and previously FDA also authorized accepting these new approach methodologies in place of reducing animal studies, which not only reduces the cost and minimizes the animal testing, it increases the efficacy of outcome of the research. And innovation, which supports safer drug and chemical development process, and it helps to respond during any chemical spills and contamination events happened in the environment, and it helps to guide the government making policies to support having a better environment. Simply, it's a sustainable path forward, helps design scientifically sound policies that balance economic growth with environmental health, builds national scientific capacity for global environment leadership. Thank you for listening. Mainly the concept of this advancing ecotoxicology and human health risk assessment with modeling and simulation is advancing the research with the application of computational tools in place of traditional animal model and testing. This framework can be applied for not only environmental exposure scenarios. As I previously worked at FDA, we do apply this modeling framework for drug development to support clinical trials and to support drug development at different phases of studies to optimize doses and to optimize doses across populations like pediatric pregnancy and other populations. Thank you all again for listening. Any specific questions related to the framework? I'm happy to take any questions now.
Thank you. Thank you very much, Dr. G. Paul, for your nice presentation. Hope all of you got an idea about chemical risk assessment from the talk of Dr. G. Paul, and she has explained about computational tools for inland risk assessment also, and also made an explain about bridging and environmental human health. With all these concluding summary, now I request all audience participants, if you have any questions and queries, Dr. G. Paul is ready to give answers for your queries. Any questions from audience? If there is no more questions, we will conclude this session. Thank you very much, Paul, all over from your place, United States of America. So we have spent your time, valuable time with us. Thank you very much from the organizing team, and on behalf of Adhikar University, we express our sincere thanks for your valuable time spending with us with your presentation. Thank you very much, madam. Thank you very much.
Thank you.
Thank you. Thank you, madam. We are closing this online presentations. Now, coming to the next session, we have a speaker with us, Dr. K. Suresh Babu, the Chief Scientist at Indian Institute of Chemical Technology, Hyderabad. Sir is with us. Now, I request our student Anusha to introduce our speaker,
the same time, I would also present some of the work which we were carried out in our laboratory for the discovery of drug use. So as we know, traditional medicine, which we have been using since several centuries, and basically traditional medicine in this ancient times, people were recognizing the surrounding plants as a medicinal plants and toxic plants based on their knowledge, limited knowledge, and that knowledge has been rooted to the different generations, various generations, and then formed as a traditional medicine as we call upon our Indian system of medicine and Chinese traditional medicine, South African traditional medicine. Like every country has its own traditional system of medicine, and of course in India we can classify it into two categories: codified and non-codified. Codified comes under Ayush Ministry, Ayurveda, Siddha, Unani, Homeopathy, and the non-codified folklore system, where even till today majority of the tribal people in the interior areas practicing it and benefiting it like anything. And of course, both the systems have equally contributed to the primary health care in India. So, when you see this picture, so we have been practicing more than 4,000 years, since 4,000 ancient times. Even we have time also, but in this present scenario where we have evolved a lot of analytical techniques and biological evolution and chemical techniques. So, the major hurdle of plant-based medicines or herbal medicines is the quality control aspect. So, in this present scenario, we can do much better because we have a lot of techniques evolved. So, next, that's why not only the developing countries and underdeveloped countries, even many other countries like US and Europe, they have also been using the different kind of traditional medicine. Of course, there's a different name, alternative and complementary medicine. So just for a glance, I gave some of the over to the counterpart of different countries. And we can come across this type of people in the tribal areas, particularly Ranguchodawaram and Araku and other regions where there is no access of doctors. So these people are called traditional healers or Parampara Vaidya. So they don't have any degree like MBBS, RMP, PhD, but they got their knowledge from their forefathers and they are serving to the people surrounded by the particularly where there is no access of hospital. Still they are doing much better and they know how to prepare the formulation and how to handle the plant and when it has to be collected. And they know pretty well because that's a traditional thing. So they are serving mankind this paper. Recently government of India also surveyed regarding the existence of these traditional healers or Parampara Vaidya. Almost across India, 3.5 lakh people are existing and they are giving their services to the tribal people or interior areas for their health care. So if when coming to the IST research in regards to the natural products, so we have been working in this area for the last more than 2 decades. And as far as our interest, we regularly interact with the tribal people or traditional people, traditional healers to understand their knowledge because they are the people of a lot of treasure of traditional knowledge. So to understand their knowledge, what are the plants they have been using it for the preparation of any formulations for any other diseases. And when we go to the lab, then we check the different databases like dictionary of natural products, whether those plants have been scientifically validated or not, those plants have explored or not for any active in respect of active compounds. several other collaborative projects also doing it. These are the main approaches in the natural products drug discovery. Biocidal approach, random approach, using the hydrogenated techniques and the phytopharma approach. So, biocidal approach is the most famous one, where most of the drugs in the present market were discovered using the biocidal approach. One of the first medicine is morphine 1803. It has been discovered by using the biocidal approach from the plant Papaver somniferum. So this involves the extraction and the screening of the extracts and fractionation, and again that fraction needs to be screened. The active fraction will be taken up for isolation of the active compound. That the active compound must be passed through the different clinical studies to become a drug candidate. So when coming to random approach, it is a completely opposite to the biocidal approach, where you need to isolate the compounds from different extracts, non-polar to polar, as many as you can. And in the latter stage, that the compounds will be screened for different targets. What happens is sometimes in biocidal approach, the active compound is very minor in nature, so that will be sometimes masked by the inactive compound. So in that case, you may miss that active compound. So that's why we are also practicing the random approach. Coming to alternate techniques, nowadays a lot of hybrid techniques are available. UPLC, HPLC, LC-MS. So by taking help of hybrid techniques, we are also working to de-replicate the known compounds and hunting for new compounds. And phytopharma approach, this is a recent one, where there is no need of purification of the compounds. However, it should be a fraction which contains minimum 4 number of compounds. That 4 number of compounds should be qualitatively and quantitatively identified. Structure also should be identified. The acidity is that fraction where identification of marker of 4 compounds should be processed as a fraction for clinical studies. But the condition is that all quantity of the 4 markers should be acidity in the all batches. That is the phytopharma approach. So this is an overview of the biocidal approach, where we need some modification. The crude extract will be passed into the vacuum liquid chromatography and to get the 6 fractions with water, different percentage of water, methanol and acetone. So here, after biological screening of all the fractions, the active compound will be identified, and once it is identified, it will be subjected to the synthesis and mechanism of action on other studies and chemical modification studies. I will give some of the examples from our own laboratory. Next. We have been working quite a long time on the piper species. As you know, piper species are very familiar with us, and piper chava, piper nigrum, and piper lagum, and piper beetle, piper attendant. They have almost over 10 to 15 species of piper. So as part of our project, we have done the work on piper chava, which is a part of many formulations, but not explored much in respect of the bioactive constant because we have taken up. And initially we did the extraction with chloroform and methanol. That methanol extract showed the anti-cancer activity, and the chloroform extract showed always the inhibition activity that is related to diabetic retinopathy. So first methanol extract of this plant has been subjected to the biocidal approach and isolated 7 compounds, out of which 5 compounds are new compounds. Again, all the pure compounds are subjected to the cancer activity. You can see the numbers. The second compound almost equal to the oxaloacetic acid. So next, the structures of these compounds were characterized by the help of 20 and 2D NMR spectroscopy, and finally confirmed with the mass fragmentation studies also, where we came to know these dimeric alkamides are forming in the plant through the Neutron reaction. So that gave the information through the fragmentation study. Coming to the next chloroform extract of fiber chava, we have isolated several compounds of different classes. So among these, usually the amide, fiberamide, we got pretty good quantity of 1 to 2 grams, and which is showing moderate activity against the auto-reductase enzyme. So generally, if we get the compound with good yield, we do some chemical modification studies to enhance its activity. So the similar thing will follow. And here, before going to the lab experiments, initially we analyzed our active compound and the marketed drugs, and finally we came to know that diamide functionality C11O, seems to be common in our compound and the marketed drugs. So we thought of keeping intact based on this, we also did some of the other analogs by doing the total synthesis. Unfortunately, these compounds are not that much potent compared to the active compounds. Still, that active compound seems to be a little bit complex. We are working to refine this activity. Next, coming to the other study, the renal artifolia, which is the part of famous Ayurvedic formulation, Darshanmal Arishta, plant formulation of containing dead roots. So, this renal artifolia was not studied properly. Regarding its active constituents, we have taken and then isolated 4 new compounds based on non-isotexate diethylamines. So, based on this, all those 4 active compounds, so 4 compounds were showed good activity on doxorubicin. So, but disadvantage is we have processed the investigation, federal investigation from the 20 kg of material we ended up 5 milligram. So, it is not sufficient for extensive biological activity like in vitro or in vivo. So, we thought of making compounds by using their own methods. So, we almost finishing that synthesis of and then doing the analogs of isotexate diethylamines. In the similar way, we also prepared like
1 second.
no, fine.
వచ్చింది.
Yeah. We're trying to get there.
Okay. Yeah.
Yeah. 20 20?
20. Okay, sir.
Yeah. Please slide more.
Okay. Please.
20. 21. Next. So these are the other examples where we follow the same strategy biocide approach from different medicine plants. There are tomadosa and there is indica, showed diabetic activity as well as the hydrolysis picatum, and also analyzed from compound, isolated compounds from the neem oil also, which showed good anti-malarial activity. Next. Next, these are also other examples where we isolated the same active compounds from using the biocide approach and did some chemical modification and still anti-cancer activity. Further, the mechanism of action also, action studies also been done, which is indicating that those compounds are polymer polymerization economy. So these are some lichens where we are also working the other source of natural source lichen, where we also look at the different compounds by using the same approach. Next, coming to the random approach or the biocide approach, as I mentioned, this is a completely opposite to the biocide approach where we have to need to prepare the different kind of extract, non-polar, polar, and do carbon chromatography and isolate as many as compounds you can, and then submit for the activity. So this is another example. So this plant, Cypradessa basifera, where it belongs to the Mailaceae family, that is neem family. So this plant has been chosen for our study based on the interaction with the tribal people from Rampachodavaram and Araku region, where we came to know this plant extract. They have been using it for common diseases and also part of for agricultural purposes. As you know, neem plant is a unique plant which is having the therapeutic value as well as agricultural value. So this inspired us to work on this plant, and we have isolated several limonoids, almost 40 limonoids out of the 15 active compounds. So and those compounds are still for anti-cancer activity, which was shown moderate activity against cancer cell line. And one good thing is Pipaper will give you just to hydrolyze the F1 and then he added some other just small groups, which really rewarded its activity, showing almost 100% good anti-cancer activity as well as anti-pedant activity also. Insecticide activity also almost showing 100% inhibition. So this is another study where this Sashangara Chinese is one of the famous plant and part of many formulations of Chinese system of medicine. And we have collected this plant from the Himalayan region, Srinagar and the Ladakh region, and studied, isolated some polar, non-polar compounds and polar compounds. Polar compounds contain benzoyl studies and studied its mechanism of action and binding studies also. Next is another plant, another study where we also collected this plant from Chhattisgarh region based on the interaction with tribal people. And they have been using it for the hepatoprotective and other diseases also. So we also made one new compound and other compound, NPT4 in quantities, and we made some chemical modification studies. And one derivative with the P2 bond, is showing good activity, and further we studied cell cycle analysis and molecular model studies also, where we came to know this is also working as a immune polymerization inhibitor. So, in addition to this, we are also working on marine seaweed, which is a treasure of our country. Almost we have more than 9,000 kilometers of coastal line, and which is not explored. And as part of our CSR mission mode project on seaweed, we have been working, and then as part of it, we have done some secondary metabolic studies on patches from marginatum. We isolated fatted nitrogenous and glycolipids, which some of them showed good anti-cancer activity, that glycolipids are showed good antiviral activity also. Next, this is also same other seaweed, brown seaweed, Dictyria dichotoma, and one of the compound from Dictyria other species, it is a marketed drug from anti-cancer activity that inspired us to study the different species. And we have collected this seaweed from the Mandapam, Rameshwaram region, and isolated 16 compounds, and some of them almost 8 compounds are new compounds. These are the success of the diterpenoids isolated from same seaweed. And another thing, another aspect, we are also working on the process development of active phytochemical ingredients from the crude extract without doing any purification study, just partition, chromatography, and washing, solvent washing. This is one of the examples where we have isolated the beta amyloid in gram scale. What we have done, we have prepared a crude extract, and that we have conducted the enriched extract of amyloid, just to wash it with different solvents, we got pure compound. That is what you can see. And you see the commercial aspect, energy of beta amyloid cost about 64,000. It's a sigma rich type. We got from 2 kg of material almost 6.2 grams, which cost about 39 lakhs. So as usual, we did some derivatives also on beta amyloid and screen for anti-cancer activity. Some of them show good activity. And here in the other aspect, we also been working on the waste to chemicals, value-added chemicals. So this is a fruit, mangosteen fruit. The fruit pulp is a very nutritious, very healthy, and pericarp. Pericarp is having very medicinal values, and tribals from Kerala and other regions are using it for different viral purposes. So we have collected the pericarp and peel of that fruit and isolated different xanthone derivatives, and based on this alpha mangosteen, that blue color compound showed good activity against chikungunya and dengue virus. So based on this observation, we made several of the derivatives by introducing sulfur and nitrogen atoms and some other planar linkers. Couple of 2 compounds we got very potential activity, which is inhibiting almost 100% of the chikungunya virus and dengue virus. This recently we got a patent also, just patent, and published also. So these are the other compounds where we have followed the same random approach for the isolation of the compounds. Next. So coming to this, to exemplify, I gave a detailed explanation of the random approach. This is one of the lichens based on this, we also conducted some cell cycle analysis and flow cytometry analysis, where we came to know this compound is arrested in cell cycle with visual by G1 phase, which is leading to the apoptic cell death. And based on it, further we confirmed with staining assays and PRP, other assays. And finally, we came to know this it is showing activity by apoptic by most cleavage of the PRP protein. And further, we have taken the help of the analytical techniques, particularly hyperanalytic techniques, to identify the compounds in picogram level. And what we have done is here, we have prepared the extract and developed a total and chromatograph to identify the compounds and by through its mass fragmentation. And we have almost identified 20 to 25 compounds. These are the structures of the compounds which were characterized through the MSMS fragmentation and mass spectrometry principles, like necropathy, rearrangement, retrodilation reaction, all those principles. And the blue color compound seems to be a virtual new compound, but that also will give justification how these compounds are formed and what is the key fragmentation, key fragment responsible for formation of this compound. So these are the key fragments and these are the fragmentation pathway we have proposed and justified for the new compounds. And coming to the LCMS guide approach, this is one of the recent approach because you can save the time and accuracy is also fine. And if you see the traditional procedure, extraction and fractionation, purification, confirmation, and once you finally, if you landed up with a new compound, then you will be excited, otherwise you will be disappointed. So it is a laborious process, that's what majority of the students are not interested to coming to the natural products research area because of its tedious job, and you will also get publications very late. So nowadays we have a lot of analytical techniques, LC-MS, MS, UPLC-MS, whatnot, everything we have. So we have taken the help of those instruments to reduce the time and to reduce the accuracy and to get the new compound. So for this, initially we prepared the sample and injected into the UPLC-MS, developed the total and chromatograph, and then those fragmentation and molecular formulas again coincided with the database like dictionary of natural products and other, identify the new and known compounds immediately, and then those known new compounds will be focused and purified through the preparatory HPLC and other methods. So this is another example which we have followed the same LCMS guided approach. Trichinella commonites, again this also been taken with the help of the traditional healers from the tribal areas, Nakachodaram and the Pada region. And this is also having the good activities against the common diseases as well as agricultural purposes. So here, by using LCMS, we have isolated compounds, initially prepared the extract and developed the total and then identified the new compound and some unknown compound. So based on this, the pinpointing of the new compound, we have fractionated this extract through the preparatory HPLC and purified again by using the HPLC and isolated the compound. Structures are characterized by using the NMR and other techniques. So for a glance, I gave one NMR and see that is for the humanoid. So in the next, same is the other item. So we have followed the same thing. The pink color part is apothecia. It's been taken from the lichen and then generated the molecular formula and molecular weights by using the LC-HRMS, and then coincided and verified with the dictionary of natural products and other databases and identified a new compound by purified by preparatory HPLC. And further, those compounds physically evaluated for different biological activity which showed moderate activity. And this is also same similar example of extract and other fractions for analyzing for the molecular weight and molecular formula and then characterized by the NMR and other methods. Next, those compounds were, since these are isolated from the lichens, which is a very good phenolic compounds known for its anti-diabetic and antioxidant activity, so validated for different assays. So by using the same analytical studies, we also we can also do some other studies where we have studied the variation of secondary metabolites from the different species of same genus. So for this we have done mRNA-MS method, where multi-reaction monitoring MS method. So in this method you can at a time you can quantify the parent diagram and fragment diagram. So in this study we have selected, generally this study is common in pharmacokinetic and other the sample preparation, optimize the different extraction procedures. So MSP extraction is giving good number of compounds and good yield. So based on this, chromatography for LCMS conditions also optimized, like energy and other LCMS column and also optimized. So based on this, we developed a program chromatograph of 5 lichen species and then identified the compounds, almost 64 compounds through the mass fragmentation studies, which are well defined in the mass spectrometry principles. So based on this, again proposing the fragmentation pathway of some of the compounds and characterize the dipside compounds and lepidol and other also other compounds also being justified to the mass fragmentation principles like paracoric acids, monophenolic compounds and monophenolic paracoric acid. So we just gave a justification also for the fragmentation and classified and put into the one class of compounds. So finally, in the conclusion of this study, we have just identified the compounds which are distributed among all the species and some compounds are only specifically existing those on the same one like that. So this study will give, because all those compounds also studied for their biological activity. So based on this study, we can also choose the active compounds which are present in this species, and then we can study instead of doing all the species. So these are a similar type of study. You want to take Symbiodus massifera and Xylocopus granata mangrove and identify some of the lichens through the mass fragmentation studies. This is also similar study, Cocolus lucidus and isolated. This is one of the drugs in clinical studies by Sun Pharma for dengue. And we have those 4 compounds are responsible for dengue activity. And we have enhanced the extraction procedure for the enhancement of those 4 compounds here by doing different extractions and developed a chromatogram and also analyzed the marketed samples where these compounds are present or not. Next. This we also propose the biosynthetic fragmentation for how these compounds are formed in the plant. So these are the another studies, same boswellic acids. We have developed our own method and then analyzed almost 40 to 60 samples from the market to verify the 6 marker compounds are present, the presence or not. So fortunately, only 2 to 3 companies are have this kind of markers. So all are qualified. So here I conclude here. Once again, I thank the organizing members for giving the opportunity. I would also like to thank our director for his support and then my research supervisor, Dr. J. Rao, not least my research students, because of their hard work only today I have presented their work, and the funding agencies, GST, DPT, CSR and others. So coming to these are my patents and technologies and some of the products also in the market, where we also these are the patents we commercialized to Samilas, Bangalore. Now we have made a patent out of it and released in the USA market. This is another method food for anti-diabetic activity and diabetic iron-rich formulation edible food like kurkure. This is also released in ISCT, presence of the Science Minister. This is a technology transfer to Amaya Life Sciences. And thank you once again for your patience.
Thank you, sir. Thank you for your excellent presentation. Starting from the traditional medicine and overview of the bioassay and all those benefits and all these with this, and finally, sir came to the novel manuscript derivatives and drug discovery of natural product in medicinal chemistry and traditional procedure even for this whatever we have isolation of natural products which are more useful to our chemistry students. Overview of this, I can say that it was excellent speech, motivated all our young students. Thank you very much, sir, from the bottom of our heart and organizing committee. And I request all participants give a big clap to our chief scientist.
Any questions?
So, without any delay, our Vice Chancellor, esteemed Vice Chancellor Madam is very busy with other important programs. Now I request our esteemed Vice Chancellor Madam, Professor today's speaker, Chief Scientist of Indian Institute of Chemical Technology, Dr. K. Suresh Babu. Sir, please accept our felicitation, sir. Now I request all audience to come up with your questions, any queries, because Dr. K. Suresh Babu is not available. If you go to Indian Institute of Chemical, IICT, Indian Institute of Chemical Technology, he is very busy there. You have seen his presentation, very excellent and eminent and meticulous. So I request the audience to come up with their questions. Any questions, queries? Sir is ready to give answers. You might today. Go to
సార్ ఇక్కడికి వచ్చేయండి సార్ జస్ట్ అంటే ఆన్లైన్ లేదా
you please hear, sir.
Nice presentation, Mr. Suresh. Okay. Thanks for taking us back to the traditional knowledge and helping us. My question is that, see, the antimicrobial resistance is a global threat, and also India is facing a lot of issues. How this transferring from naturopathic products, how it is going to have an impact on the AMR, antimicrobial resistance in India?
Microbial resistance, we have also been working in some other project which we have not covered here. It's a really running program right now, and even ICMR and other funding agencies also giving generous funding to develop to work on this AMR. So I can say. There is a solution plant-based traditional medicine for AMR.
Yeah, that's
We have been working on this to address this AMR issue for working on plant-based and also some other microbes, marine microbes.
great.
Any more questions? Students, especially from the young students, the person like Dr. K. Suresh Babu, who delivered a great lecture, you cannot see that kind of meticulous lecture. So, sir, that natural products isolation, bioassay, which is more fit to your even pharmacy or MSc organic chemistry or whoever pursue your course, even PhD course, and even LCMS, DCMS, everything he explained in a very fantastic way. I expect one more question from audience, even. So if there is no question, I'm ready to ask one.
నేను ఇక్కడే ఉంటానమ్మా సాయంత్రం వరకు మీరు ఫ్రై అయితే యూ కెన్ కాంటాక్ట్ మీ.
I have one question, sir. Suresh Babu, I have one question. So we have presented so many compounds and so many derivatives we have presented, and it's kind of one library. It's not that much of easy. And while you are confirming, while you are going to confirm with the spectral data, all what we have right from individual IR up to even the ultra modern, even 2D NMR and everything. Have you used this depth and 2D NMR and COSI-NASI also, sir, while you are confirming the all structures?
We have used 1D and 2D NMR. 2D NMR depth 135, depth 90, and proton COSI HSQC, and HMBC, and NOSI. So every technique has its own significance. So we have used all the techniques for confirmation, proper confirmation. Finally, if the compound is crystallized, finally we study the crystal studies also. That is the ultimate.
Even when you do X-ray crystallography also.
X-ray crystallography, provided compound should be crystal.
Yeah, I request all youngsters to observe this kind of that presentation what our speaker is saying that all kind of advanced spectroscopy, even co-signalcy, what he said, everything, the depth spectra and everything, that's more important. Keep it in mind. Synthesizing is one aspect, isolation is another aspect. Isolation is not that much of easy. And finally, confirmation is also another beautiful technique. So you don't have these kind of facilities, but the institute like where Dr. Suresh Babu was staying at the Indian Institute of Chemical Technology, IICT, is a very good institute. Sir is working there as chief scientist. So that's why you should observe this modern techniques, ultra-modern techniques for the confirmation of any organic compound. So that's the thing what I want to bring to our young mindset. And sir is available up to evening. If you have any queries, and now you are unable to coin your question, if you have any shyness, then you please contact directly to Dr. Suresh Babu. So with this, if there is no question, I can conclude, sir. Please. So thank you very much, sir, Dr. K. Suresh Babu, who is working as a chief scientist at Indian Institute of Chemical Technology. Actually, from the bottom of my heart, from the organizers committee, I want once more time expressing my sincere thanks, sir, for your arrival to our entire this international conference. Thank you very much, and give a big clap again to our Dr. K. Suresh Babu. Thank you very much, sir. Now we'll go to other session, online session. We have two are online. One is from Muscat, Dr. V. Devadas and Ropavalli. And just it is a very short presentation, 10 to 15 minutes only, and time constraint is there. You know.
Okay, sir. Thank you so much, sir.
Ropavalli.
Yes, sir. Good morning, sir. Good morning, everyone, and all judges and all dignitaries, all participants in the online presentations. Namaskar, everyone, sir. I am Rupavali Tanabadula, sir.
Madam, Ropavalli, line lo undi.
Yes, sir. Yes, sir.
Wait a minute. Please wait a minute. Please wait a minute, madam.
Okay, sir.
Yes, sir. Yes, sir.
Can you please go ahead and present your presentation?
Oh, yeah, sure.
Yeah. Rupavali garu, meeru stop cheyandi sharing.
Okay, sir.
Now you can go ahead to share your screen.
Yeah, sure.
Dr. V. Devadas from Muscat. Now he is going to present his oral presentation. Please, Dr. Devadas garu, this is the convener from the international conference, Professor Mohan Reddy. So please present your presentation, sir. Please.
Shall I start? Hello?
Sir, please start your presentation. Yeah, we are able to see your presentation.
Yes,
Please.
okay, thank you.
Please.
Good morning all of you, and I thank you for the organizer for giving an opportunity to present this paper. My topic of this research is a sustainable, energy efficient and waste minimized indirect electrochemical oxidation approach for the aromatic aldehyde production using regenerable acidic methane sulfonate. This overall content is covering about the abstract introduction, the principles behind this technology, and the flow diagram of the electrochemical and cyclic process, then experimental conditions, result and discussion, and conclusions. Introduction. You know, the substance of benzaldehyde used in intermediate in the production of flavor and fragrance and pharmaceutical specialty. These compounds are mostly produced by air oxidation or oxidation with the use of metals such as dichromide or manganese dioxide. So these conventional methods result in poor selectivity and yield and serious waste disposal problems. So the indirect electro-oxidation gives a solution for such kind of the environmental pollution. This indirect electro-oxidation substituted toluene using steric mediator offer a facile and eco-friendly route for the production of respective benzaldehyde. This process is cyclic and involves electrochemical regeneration and reuse of the mediator. Use of steric mediator in methane sulfonic acid medium in a particularly advantageous as it avoids the technical problem associated with the other acid media. So here I am going to summarize that in what are the advantages of methane sulfonic acid as a medium using here. Very strong organic acid. Yes.
Slides more. Can you do your presentation? Only we are seeing the first page paper presentation by the.
Okay. But I am moving then sixth slide.
No. We are not able to see the sixth slide. We are able to see only the first slide.
1 second. I will look at this one. But I just moved that in sixth slide.
What is the title?
1 second. Looking at
do that. Go to presentation mode, please.
Full screen.
I mean.
Yeah, sixth slide. Okay. Go ahead. Methane sulfonic acid, right?
Yeah.
You put F5.
Now it's moving. It's moving. Hello?
Just go to the next slide. We'll see.
Yeah.
No.
No, got the principle?
Actually, you are in typing mode. You have to change the mode. But you can check your desktop bottom right side. You have to click the
Bottom right side.
speed mode.
Just taking that in right side.
Yeah, that one.
Got it?
Not yet.
Yeah.
Click it properly. Okay, anyway, you please change manually every slide and move to next slide.
Yeah. When I look at this one, that will so that
It's
I
not
can change.
automatically moving, so you please do by manual.
Yeah, manually I can do it. Okay, right. Methane sulfonic acid has advantages over the other media because it has a strong acid and it is highly thermally stable. It does not generate any decomposition product, and it is very easy to biodegradable, and is lesser than that in sulfuric acid, and it is also that in stability towards oxidation, and it gives a high selectivity over the wide range of different substrates. And another important thing is that when here it has the high solubility in both serous and acidic salt. Now here the principles behind this electrochemical the whole method is it involves in two different type of the reactor. One is called as electrochemical reactor, another one is conventional chemical reactor. The electrochemical reactor, there is an electrochemical oxidation reaction takes place in which that means serious ion are converted into steric ion in the electrochemical reactor. So the electrochemical reaction is typically carried out in a divider using cation exchange membrane. Here that's a reaction, Cr3 plus are converted into C4 plus. This is a main reaction, and the side reaction also taking place between the water and is oxidized and releases oxygen atoms. Here the chemical reactor in which that means the conventional oxidation reaction of organic compound using the steric mediator is taking place, which is reduced to the series. Both the electrochemical and the chemical reactions occurs at room temperature. So the organic reaction is typically in liquid form and is charged to the reactor dissolved. The chemical oxidant which involves in two phases, an organic and aqueous phase, and after the oxidation the two phases are separated, and the organic phase is suitable process to recover the product and the solvent. The aqueous phase is suitable treated to remove the trace of organic matter and recycle in the electrochemical reactor for the serial generation. Initially, that we conducted the cyclic voltammetry studies to identify the potential of the oxidation of the series to series. So these cyclic voltammetry studies are carried out in a single compartment cell, and glassy carbon used as a working electrode, platinum used as a counter electrode, and saturated caramel used as a reference electrode. From the diagram, it was observed that the oxidation of cerium 3+ is taking place at 1.48 volt and also shows a well redox behavior in the methyl sulfonic acid. And overall, the diagram is explained in this flow chart. In this flow chart, you see here, so this is an electrochemical reactor. In this electrochemical reactor, here that means the analyte is charged. The analyte contains series ion. It is oxidized in the electrode and steric. So the oxidized form of steric in the aqueous solution is charged with chemical reactor, where the chemical reaction is taking place. Here, along with the steric ion, that means we are charging this paramethoxide toluene in this chemical reactor, and this paramethoxide solvent is dissolved in a solvent, suitable solvent, and this overall the chemical reaction taking place. After the chemical reaction, it is charged with the separator, where the organic aqueous phase are completely separated. Yes? Yeah, okay, right. So after this separation, the aqueous solutions are treated for the regeneration. Again, it is passing through the electrochemical. So that's why here no waste is generated. All the reactants are able to recycle and reuse, so that we can conduct it in millions, thousands and thousands of the cycles. And the separated organic phase has undergo that vacuum distillation, where the solvents are recovered. Again, it's used for the chemical reaction. And this crude product undergo the fraction distillation. There we are separated unreacted and that product. So the product, overall the product that we are getting here is almost consistently more than 80%. Now here some of the few examples and experimental results I am going to give you. Initially, that in the bench scale studies, it is conducted with a 5 ml capacity PVC cell. Here different type of electrode we used: platinum, titanium substrate insoluble anode, and cathode is the stainless steel, and analyte serious methyl sulfonate, cathodite is in aqueous methyl sulfonate. Studies were conducted to optimize the electrochemical reaction parameters such as current density, concentration, and liquid concentration, acid concentration, etc. And here some of the results that went here. The chemical oxidations are conducted initially at 500 ml RB flask fitted with the stirring, oxidant, and steric methyl sulfonate, and solvent, dimethyl chloride, and acid concentration. And studies were conducted to optimize chemical reaction parameters such as acid concentration, temperature, solvent and solvent ratio, reaction type, final yield. So here some of the few results that I'm going to say here. After then optimized this one, we conducted in a big scale level, that is pilot scale level. Here that we are using electro sensor, and the electro sensor has been designed on the line of the traditional plate and frame filter press used in chemical industry. So the electrode sinks and compresses a parallel plate electrode stacked together with the ion exchange membrane suitably placed between the electrode. The electrode and membranes are attached to a specifically designed injection molded frame made by the polymeric material. So here the anode was and dynamic stable anode with a cathode stainless steel, naphthalene 2,3 cation exchange membrane used as a separator. Electrolysis was conducted in a bench mode with the circulation of analyte and catholyte from separate compartment. Here the chemical oxidation reaction also conducting in 20 liter capacity. The reactor was provided with a ketene mantle with the ketene reactor side. Glass stirring, the glass stirrer connected with a geared motor side system was used. The reactor outlet was connected to a glass condenser and the system was also provided with a reflex control. Here some of the results I am going to show you here. And electrochemical oxidation of cerium to cerium. And here different type of electrode initially we conducted. Platinum is given good and specific energy consumption. It is around 0.776 kilowatt hour per kilogram, whereas the titanium substrate insoluble anode is given 0.84 kilowatt hour per hour. Comparatively, the cost of the electrode, that means TSA is a very fine electrode and very cheaper electrode. Of course, platinum is giving good energy consumption. But TSA, the cost of the price, I mean, it gives.
Please go to conclusion because we are running late. Please conclude
Yeah.
your time over. Please go to the
conclusion here. The methane sulfonic acid is an ideal electrochemical reaction and hence it is a potential candidate for the electroorganic synthesis. Methane sulfonic acid has a very good advantages over other acids. So ceric methane sulfonic is stable in both dilute and concentrated methane sulfonic acid and have a good solubility. A well-known compound like paramethoxytoluene, para-tertiary butyltoluene, ethyl benzene were taken up for investigation of this system. So this indirect electrochemical synthesis in methane sulfonic acid using ceric mediator indicate a range of compounds can be synthesized with high yield. A typical case study was conducted to scale up the study related to the paramethoxybenzaldehyde. Also been taken up. The results show that electrochemical process is successfully scaled up. So that's what has been my presentation. Thank you for any questions, please.
Thank you, Dr. Next, there are no questions from the audience. From the article university, we thank for the nice presentation, better presentation. Thank you very much, Dr. Next. Thank you very much.
Thank you. Thank you.
Now we'll go to the next on the paper presentation by Rupavalli. Rupavalli, are you there?
Yes, sir.
Yeah, you have, please listen carefully. We have only 5 minutes. Your time is very less, 5 minutes. You please complete within 5 minutes, okay?
Okay, sir.
Over to the power, please. Please share your screen. Please share your screen.
Yes, sir.
Please select your PPT winners. Yes. Yeah, your time is only 5 minutes. Let us go. Yeah, we're able to see. Go ahead.
Okay, sir.
Go ahead.
Namaskar everyone, sir. All dignitaries and all judges also, all participants also. Welcome to today's my presentation. I am Rupavalli Nalabathina. PU, and now I am working in lecturer in physics in SKST Mahila Kadasala in Tanuku. Under the guidance, actually in this month I am presenting the thesis also at this under the guidance of Dr. Nabapanna Chakrabarti, Assistant Professor of Lovely Professional University. And today's my topic is investigation of physicochemical properties of soluble vitamin B's with different solvents. And now this is an outline for today's presentations. Let me start with one by one. Introduction and objectives are one by one. I will start one by one. So let me start with an introduction. Today's how to investigate the physiological properties of different combination of mixtures. How to presentation in this. Nowadays are using these techniques, ultrasonic technique. Now first of all introduce to what meant by ultrasonic. Ultrasonic is a branch of acoustic focusing, and this is very high frequency waves and above human audible range 20 kilohertz. Already I mentioned in that figure in this slide, sir. And 20 kilohertz and very high directionality, and ultrasonics can't move in a vacuum. The ultrasonic waves are constituents very frequency, shorter wavelength and sound waves. These waves are travels at the same velocities and same particular medium of the throughout homogeneous medium. Their velocities remains constant. This is the first of all in this technique is the non-destructive technique because of any damage of the samples can't analyze to samples to preserving integrity of the material and substance and being studied to understanding the ultrasonic and thermodynamic properties of liquid mixtures is crucial to unreveal intricate or intra and intramolecular interactions. First of all, the density is measured to provide the information volume changes occurring the following insight to the solvations to ion pairing the process. And the next one, velocity is measured allows further determination of the compressibility of the systems, which is directly related to this intra and intermolecular structure changes taking place. Both the two combinations and ultrasonic and thermodynamic combinations data provide the comprehensive understanding thermodynamical behavior of the vitamins and different combination of the compounds all in an aqueous environment. And then so many applications are there in they are widely using in these applications so many fields such as food and cosmetic and materials and pharmaceutical industries. And then now the significance of the ultrasonic and thermodynamic properties of liquid mixtures and provide in the significance of provide to in-depth knowledge in inter and intramolecular interactions to important information about solvation and solvation molecular and association to influence temperature, pressure and composition properties of the mixture. And the physiological properties means density and ultrasonic velocity to density and ultrasonic velocity to pure component and different mixtures, and used tools and investigate pure components and intermolecular interactions of the mixed combination of the mixtures. And then after that, these three are objectives of this in this study to find the density and speed of sound in a liquid mixture, water soluble vitamins and organic compounds like carboxylic acids, glycols, or everything. Everything is there and different temperatures and different concentrations to calculate the various acoustical and thermodynamic parameters and different values and different temperatures, and to analyze the molecular interactions of the calculated thermoacoustical parameters. Next, after that, the research methodology. In this research methodology to analyze all mixtures, first of all, weighing the samples, then and prepare the solutions, and then these solutions to inject it to Andhar DSA. This is the Andhar DSA to inject it to with the help of the syringe, and to then after that find the values and density of the velocities, and then find the volumetric and acoustical, means thermodynamic and acoustical parameters, and finally got a molecular interactions of physiological properties. And then this is the main in this study the main heart of the functioning in this physiological property to find the physiological properties. First of all, introduced to Antarctica DSA. This Antarctica DSA is the YouTubed hollow glass tube. This is the made up of borosilicate glass. The liquid samples filled with the YouTube with the help of the syringe, and the YouTube made the vibrating at frequency to measure two independent physiological properties by accuracy. 0.01 degrees centigrade with stable results. And this is yes sir.
Yeah. Your time over. Can you go for?
Yes sir. Yes sir. Few minutes time.
1 minute. Please conclude.
Yes sir. Yes sir. And then measurements. And the DSA will measure the both density and velocity sound at same times, and the combination density and sound velocity to measures at a time. And next one, these all are my water soluble vitamins and different organic compounds. And then after that, the experimental theory. These parameters are using in this study to determine the investigation of the physiological properties of these vitamins and different organic compounds, and adiabatic compressibility, molar volume, free length and free volume, and internal pressure. These all are significance of the parameters. One by one, adiabatic compressibility is lower compressibilities indicate tightly packed molecular stronger interactions, and free length also distance between the molecules. Excess values are revealing the presence of molecular interactions. Internal pressure is the interaction strength, variation of interaction strength also. And then these all are some few plot the diagrams and different combination of pictures, data and both intermolecular free length and adiabatic compressibility. And then finally applications. So many applications widely used in this technique. So many applications are pharmaceutical industries and cosmetic, very useful to safe and effective skin care products. And biological research help the understand interactions to biological research, and food chemistry support to stability mixing the fortify the foods, and material sciences and medical sciences. Also, so many industries are nowadays using in this technique. And finally, in conclude, my topic is water soluble vitamin shows the properties that depend strongly on their interactions with the different solvents, and this knowledge support better product stability and safety safety for these mixtures. And ultra studies help reveal the acoustic and volumetric property of intermolecular interactions of behavior. And finally, the further work should be focused on solvation behavior and density and speed of sound of the giving a mixed combination of water soluble and different organic compound solvent systems. And these all are using these references in this my present study. These all are, sir, and thanking you. And I am grateful for the opportunity for the present my work in this conference, and thank you so much, sir.
Okay, thank you, Rupal. Very nice presentation, and request all our to do that. So we have explained about all the water soluble vitamins and with ultrasound studies and all other future techniques.
Yes, sir.
Thank you very much for saying.
Yes, sir.
Rupal, thank you very much. Okay.
Yes, sir. Thank you, sir.
Now we'll go for oral presentations. Now I request all participants who came with your oral presentations, come here in our laptop. You just paste your presentations, and we will make a note, and we'll give a chance just 5 minutes. You remember that? Just 5 minutes for your presentation. Yeah, how many people are there? If more people are there, we'll go to parallel another room also. Otherwise, we'll go here only. How many people are there? Please come forward fast. How many people are there? 1, another 1, 2, 3, 4, 5, 6, 7, okay. ఎంతమంది 8 members. మీ నేమ్స్ అన్ని ఎంత నేమ్స్ సునీల్ నేమ్స్ రాయండి ఒకసారి. Rest of the people, you can if you take outside tea is there. You take tea and come back. But don't make delay because you are running lagging. You be in the convention center very fast. Chairman, come on.
ఫైల్ పేరు అనమాట అందులోకి యాడ్ చేస్తాను. మిగతా వాళ్ళు కూడా మనం అలాగే వేసేస్తాం. ఆడియో అన్నీ ఇదే ప్రొసెస్ వేస్ట్ అయిపోయిన తర్వాత విండోస్ పెట్టుకుని నేను చేస్తాను. లక్ష్మీ అది ఈ నెంబర్కి ఇచ్చిన మిస్ అయిపోయింది సార్. బ్రేక్ అయిపోయినప్పుడు అందరూ రెడీ అయిపోయింది. మీ పేరు కూడా మెసేజ్ చేయండి సార్. మీరు ఫైల్ పీపీటీ పెడతారు కదా వాట్సాప్కి, కింద మీ పేరు కూడా పెడితే మీకు నేను కూడా సెండ్ నేను ఫైల్తో పాటు నేను సెండ్ చేస్తాను. మాట్లాడండి సార్ వాళ్ళు సార్ వాళ్ళతో మాట్లాడండి. విజయ్ రీసెర్చ్ అల్లాడు రాజు కంపెనీలో ఉందా వాట్సాప్ చేసి
సాధారణ మెయిన్ షాప్ బెంగళూరు డైరెక్ట్ పెట్టారా పెట్టి అడ్వర్టైజ్మెంట్కి అక్కడ తెలియలేదు అందుకే డైరెక్ట్ పెట్టి కూర్చున్నాడు అటువంటి బ్యాగ్ ఉంటుంది కింద ఉన్నాను అది బ్యాగ్ సైడ్
ఈలోపు
అన్నంలో పెట్టి సాగు
Thank you. our two distinguished speakers. The first speaker is Professor Kalluri Ranganathan from Banaras Hindu University. He is a professor at Banaras Hindu University. Now I request Professor Kalluri Ranganathan on to Triyas to chair this oral presentation sessions. I request all participants to give a big clap to our Please be seated. Now I request the other speaker of this international conference and distinguished guest, Krishna Reddy Garu, please come under the dance to chair this oral presentation session. Please. I request all participants to give a big clap to Krishna Reddy Garu. Please be seated, sir. I request Ranjana to please accept our token of respect.
లిస్ట్ ఏమి ఏదంటే రెడీ పెట్టింది లిస్ట్ ప్రకారం భారత్ అంటే ఆదిత్య
Bharat from Aditya College. Are you ready? Come here. Present your presentation. Bharat from Aditya College. What is your name? So your presentation. Is it? Okay, please.
A very good morning to everyone. My name is Kumar and I am from Aditya Pharmacy College. A trial detect and blood analysis for epilepsy. This is a specific design to help people who are suffering from epilepsy and epileptical seizures. These are the basic concepts I am going to talk about. So, principles and the concepts of seizures, adversity studies, working mechanisms and applications. So, epileptical seizures. Epileptical seizures means an abnormal electrical activity resulting in abnormal working of sensory, motor and psychomotor nerves. So, across the globe, 51.7 million living epilepsy condition people. So in India, there are like 3.5 million. All over the world annually, according to WHO, 1,40,000 deaths occurring every year. In India, there are like 31,400 deaths has been recorded last year. So we have designed a specific design that could channelize the seizures, detect seizures, and having a proper medication. Types of seizures: clonic seizure, clonic seizure, chronic clonic seizure, atonic seizure, myoclonic seizure. Not only epileptical seizures, these design can also help in detecting seizures, like caused by genetic factors, brain injury, and stroke infections. Okay, let us see. To tackle seizure, we got into three main fundamentals. First one is detection, second one is diagnosis, and third one is medication. So, what is a transdermal epileptic patch? What is is a transdermal elliptic pad. Transdermal elliptic pad is a bioengineering device integrated with AI modulation phases to help people who are suffering from epilepsy. It monitors, surveils, and reports the drug information that the people who are using this device. So these are the main principles behind this wearable device redesign: detection, nanodrug formulation and nanochip, nanomicrochip, and interfaces. Detection. How does this wearable device detect the epileptical seizure? A nanomicrochip and an interface system. See, nanomicrochip. This nanomicrochip detects the seizure and diagnoses the seizure and records it. It detects the electrical activity of a person, which is raised differently to a normal person and a seizure activated person. So how does this system detect epileptical seizures? The surface EMG we used in this has algorithms like root mean square and fast Fourier transformer. So how this device takes the signals? First it takes up the raw signal acquisitions and then amplifies the signals, and then it produces and sends these recording waves to oscilloscope meter, where it diagnoses the seizure activity and sends an alarm to the taker and has a brief episode, like it sends signals to a caretaker, it sends signals to a nearby hospital. So immediate activity of helping happens. So antiphotic system is how the drug medication is going to reach the suffering people. This is the working mechanism of this wearable device. First, the EMG detects the epilepsy and activates the microchip. So then it sends signals to caretaker and activates the diaphragm brain to release the medication into the blood. So the drug releases through microrange into the circulation, and that's how treatment works. We have overcome some of the challenges. The first one is steady drug release. Using a nanodrug formulation, we have passed the first pass of the metabolism, and it's a non-invasive administration, so it is convenient to use and having a reduced side effects. Thank you.
Vijay. So your presentation is for 5 minutes. Huh? Okay. Please go ahead.
Good afternoon to everyone. First of all, I would like to thank AKM and publishing unit providing this platform to present my work. So basically, I am working in the field of vibration spectroscopy. So investigation of structural analysis and molecular interactions by using EMG studies and molecular docking studies. So next slide, please. So next slide. in the form of atoms, and then I simulate with that dynamics. Then I check the reactivity. So, and these what helps to for green chemistry aspects. So we need not to prepare any compound for the physical. So we just check the compound by using computer. So we will work on it. Then finally we see the exact reaction mechanism. Then we will implement the application for performance. So this is my main core methods. So we have classical methods and quantum methods. So nowadays many people working on quantum mechanics. So quantum methods. So basically I trust and I believe classical methods give you accurate results than quantum mechanics. Why? Because theory is important than results. So we work on the theory, then we will get the result ultimately. So even I am working in the quantum mechanics, but I trust classical theories only. So for these methods, we have a lot of methods, aviation methods, and DFT methods, and spherical and quantum methods. So basically, I am working in the field of density functional theory. So we have a quantum model and principal theories. So for these techniques, we have to investigate, we have to see what things are happening inside. So for that reason, we must know the spectroscopic techniques. So absorption techniques and emission techniques we have. So for that, we are all very well about these spectroscopy techniques. So FTIR and Raman spectroscopy helps to investigate the vibrational mechanisms, and UV and X-ray diffraction, it gives absorption spectra and structural information also. So I am using both the techniques. And plan of my work actually I just given before. So DFT is our platform, and result speaks by using spectral observation only. So finally, I took any compound by using computational methods. So I took the compound and I optimized with this basis set, and the calculation and scaling feeds, everything gives the accurate results to obtain the compound mechanism. So this is my compound actually. So for this compound I optimized and I studied some of the results. I just show you some of the results by numbers. But here I am not telling about numbers. I am telling about the insights. Okay. So this is UV. We can observe these techniques, absorption levels of any compound by computer. It itself gives the reports. So this is FTIR. So the FTIR gives molecular vibration spectroscopy, the complete information from the fingerprint regions to highlights of the compound. We can see clearly by using FTIR. So then homolumos. The homolumos gives electrophilic and enterophilic charges, and the molecular orbital complete scenario, it reveals the data. So this is some of the interesting study. So LBO, natural bonding orbitals. So the only bonding interactions and bonding orbitals, it reveals what is the exact scenario of the compound. So these are some of the results I taken from the Gaussian software. So in two different basic sets, and one is basic level and another one is extreme level. So basic we 3-11 using, and the extreme present many people are using 3-11 GDP. Right? Okay. So you can. So these are some results, and I published many work in that. So recent publication in the chemical. So these are the main motto of my work is to investigate the compound from the ground level to so these are some so finally the motivation comes from the computing is about insights, not by the numbers. So even though I am showing the numbers, the insights revealing the concepts. Thank you. Next presenter is Pujita.
A very good afternoon to all and all. Myself Pujita from Dr. Indian College of Food Science and Technology of the University of Acharya Indian University of Bapatla. And my friend, hello everyone, and myself Charlie Bindu. We both are from same standard. And today we are going to discuss about the topic called construction of traceability in functional foods. It's a review article and it's a current trending topic. Today we discuss about some context, the important context called what is traceability and what is functional foods and its incorporation. So we can discuss now today about what is traceability. Traceability it means to track a product from its initial to its final sale, and it is defined by codex alimentarius commission. Today's consumers are very conscious about where the product is coming and it is distributed and produced and how it impacts our environment and our society too. And these are some key components of the traceability which gives our food safety and regulated compliances, safety and supply chain optimization. First we discuss about food safety, which gives the minimized traceability, which minimizes the risk of the food. And some laws are introduced here, which is Food Safety Moderation Act, which makes the mandate of specific tracking and tracing of certain foods, and supply chain optimization. It gives and predict the food, which gives the safe food to the future. And these are some 4 pillars of traceability. Those are product identification, data to trace, product rule, and traceability tools. First, the product identification. It includes the physical characteristics like weight, volume, and life cycle of the product, and the length of its life cycle. By some of the applications like QR codes and barcodes, RFID tags, these can help us to track about the product, where it is coming and where it is going, and it is reaching to the final customer. And product tracing is the lead management, which is basically managing the identified product from point of the manufacturing and to the final sale. And traceability tools are the main objective of traceability for data communication. And these are some types of the traceability, which is forward traceability from the initial origin to the final sale. The traceability process will be beginning from the initial and to the final. And the backward traceability, which is from the final to the initial. Bidirectional traceability, which is combines the both forward and backward traceability, which leads between both directions. Version traceability is the software traceability, which tells about the time updates of the product. And these are some main important applications about traceability. Barcodes and QR codes, RFID tags, IoT humidity and is the product was ripened or unripened about that. And the DNA traceability which tells about by using the genetic fingerprinting about a food product. And blockchain also used it for recording the every step of the supply chain. Next. Functional foods are molecules for human health as it has effective nutrients which are very useful for human body and they are used as a food supplements. And they were first introduced in 1980 in Japan. FOSSG, Food for Specific Health, conceived the first food claim on the labeling and aimed at reducing the cholesterol level. This was the very first where the functional foods are used. There are very functional foods in that we're going to discuss about very few. Garlic has bioactive compound and very low LDL. Cinnamon it improves insulin. Yogurt it supports gut health. And kimchi it's a Korean traditional dish. Okay. Thank you everyone for your patience listening. Thank you.
Good afternoon to all. Good afternoon to my speakers and colleagues, everyone. I am Nirmala Jyoti. I am pursuing part-time PhD and the director of Government Research. Today I am presenting a topic on an efficiency strategies of N-substituted hybrid derivatives. In that content, I am discussing about what the topics here given. Those topics I will discuss during the semester. So, why I am choosing the pyridohybrid derivatives? Because in biological way, heterosexual compounds like pyridines and pyridines plays a key role. That's why I am choosing pyridine and pyrimidine moieties for synthesis purpose. Just like this. Scope of work. Here, in our work synthesis, we are choosing simple steps like cyclization, esterification, and hydrolysis. By using these simple steps, we want to prepare biologically active compounds like derivatives, compound and derivatives. But they are used in huge quantity like herbicidal, anti-cancer, and anti-HIV agents. The specific object of this work is pyridine and pyridohybrid as a therapeutic agents. Those are widely used for anti-cancer and antimicrobial and antibacterial activity. The importance of the pyridohybrid derivatives is, as you know, all of you know, nowadays a number of diseases are caused through the bacteria and microbes. The activities, the biological activities of pyridohybrid derivatives high in that nature, we are selecting this compounds. Previous work. Why we are choosing pyridohybrid derivatives is, here oxalic acid, malonic acid and pyridoic acid. Some of the people worked on this area. By changing some of the moieties, we want to plan better. So here is our present work. Here first initially we started with the furfural through the bromation, cyclization and hydrolysis. After getting the hydrolysis, we got that N-substituted pyridohybrid carboxylic acids. Coming to next step. So after the synthesis of this compound, we are changing the substitutions at a nitric group. Here R are the different types of the derivatives. From this we can get
Srinivas.
Thanks for giving a great opportunity. My name is Srinivas. I'm the research scholar in Technical University under the guidance of PhD Andrews sir. Next. This topic is chemical reaction content in alignment of substance by ancient elements. They are also considered couple of mass substances were established as separate by quantified chemical reaction content in alignment of substance by using the Gerlach's eclipse column. Then the product is a chemical reaction that is the symbol. We develop the material symbol in an approach to animation. That's a positive item. And we found the result as this is specification in 60 ppm and it can be covered by 6 ppm to 120 ppm. 6 ppm is the annual level and 2 ppm is the level of this multiple myeloma and mild pressure syndromes, mantle lipoma, corporal lipoma, and marginal zone lipoma in suspect patients. And this the development of substance in the process of development of substance that chemical reaction is used as a reagent. In the process of we are using the palladium for NO2 to NH2 conversion. However, palladium chemicals are not meeting our controls, and to reduce the palladium content, we use the metal cylinder. So, and the impurity whatever the chemical reaction is structured as the reagent system. For the purpose, we are using the chemical reaction as a development impurity, and as the TTC concern, we control the 60 ppm as a specification limit for that. This is the chemical reaction structure. This is the chemical structure. Next slide, please. These are mechanism methods we use. Starting in the alignment of substance and chemical impurity standard and other impurities and we are using ammonia format as a buffer and external is the solvent and we need to water. And instrumentation we are using sites with the double trap and with anti-solvent and we use the positive ion for market for the preparation disease. The market next slide. Here is the discussion of the development operations. We select the after market ready to market with the amount of market we select as the proper and estimated in the selected solvent. Section of column. So the eclipse created we are using as a column. And external buffer we are using 50% or 50% as a diagram. Intensity buffer we use diagram. But intensity buffer. And column we are using column over centigrade, sample temperature maintained for 20 centigrade. These are materialization, whatever the system should be. For allocation time, we have found the percentage value 0.12% and the response rate percentage value we found 1.5%, which is the acceptance criteria less than 15%. Next slide. This is the specific results. Diameter is separated from the In the DNT, it was covered from LOQ to 200% level, LOQ is 60 ppm, and 200% level is 120 ppm. So we found the 0.09 and percentage level 0.01. The conclusion is that we found the option 0.98 and precision and percentage of everything is not accepted criteria. So everything is weighted by within index actor average against Q2 order against consumption. Thank you.
Next speaker is Lakshmi Madhavi.
Good morning all, my name is Lakshmi Madhavi, working as an assistant professor in Malaysia Pharmaceutical Sciences at Agricultural University. I'm also a research scholar at Rajendra Nagarjuna University. Today I'm going to present about the breeding with the extraction, antioxidant value inside the seeds, the pods will not immediately change the color. Based upon that, some categories we have put, so which will not easily get degraded. So then immediately after peeling, just 2 or 1 hour later, immediately come out for the extraction.
Good afternoon to one and all. My name is Shanti Kumari. I'm a research scholar, Department of Computer Science and Engineering at Nannayana University. It is my privilege to attend this FBCBS conference, and even though I came from the CSE background, my work
Good afternoon, everyone. My name is Alan Rajkumar, PhD research scholar from the Department of Chemistry, Victoria University. So, today my presentation is on how climate change will influence, how land use, land cover changes will influence the climate change. So, the title of this presentation is Land Use and Land Cover Dynamics for Climate Change Adaptation in Koringa Wildlife Sanctuary. So, next slide. So, before that, what is climate change? So, climate change refers we have the greenhouse gases like CO2, CH4 and O2. So, those will affect the climate. So, based on that, we will change the climate. So, next one. So, we have two types of, next slide. We have two types of strategies. First one is mitigation. And in mitigation, we will reduce, mitigation means, so reducing or preventing the emission of greenhouse gases. And next one is adaptation. So, in adaptation, adjusting nature or human systems in response or actual or expected climate impacts. Next slide. So, how we regularly see changes these climate changes by deforesting and soil disturbance or loss of natural ecosystem and agriculture and urban expansion. Next slide. So, for this study, I have taken the land use classes like mangrove, agriculture, and degraded mangrove, coastal vegetation, water, aquaculture, built-up area, mudflats, and sand. Next slide. So, what are the research objectives? To analyze the relationship between land use and land cover with the climate change. Next slide. And for this, I have taken a study area of Koringa Wildlife Sanctuary, which is a potential Ramsar site. So, which I have 235 square kilometers. India is the second largest mangrove ecosystem, and it supports 120 plus bird species, and it contains 25 plus mangrove species. And it is located in Godavari Delta, which is Kakinada. Next one. So, for this methodology, it consists of study area selection, then data collection, with pre-processing. In pre-processing, I do in GE. After that, I will do the LSC classification by taking the LSC classes. And after the post-processing, I will do the satellite images. I will analyze the satellite images in QGIS. So, for this, I have used Sentinel-2 from 2019 and 2024. Next slide. So, based on that, I have got the results like there is a change in water bodies, there is an increase in water bodies, and there is a decrease in mangroves, and there is a decrease in agriculture, and there is increase in the built-up area like there is expansion of aquaculture, and there is an increase of degraded mangroves, and there is a reduction of sand, and there is increase of coastal vegetation. Next slide. So how this will affect the climate change? So if the mangrove decreases, so there is a reduction of sequestration of carbon. So why? Because if you compare mangroves and the terrestrial forest, so there is a 10% increase of carbon sequestration is present in mangroves. So compared to terrestrial forest, so that's why if the mangroves are decreases, so there is a leading of higher CO2 levels, and the coastal vegetation increase, there is slight improvement in carbon, and sand area decreases, there is a suggestion of coastal erosion, and there is an increase of water bodies, there is a increasing of aquaculture. So next slide. So by this I have concluded. So the land use changes shows major ecological shift. So by this, so climate change mitigation strategies like mangrove restoration and climate change adaptations like coastal buffer zones. So next slide. So these are the key recommendations like check the pollution, and those are some annexes. Next slide. These are the differences, and I will acknowledge Andhra Pradesh Forest Department and BTM University for giving the grant, and I would like to thank Adhikavi Nannaya University and my supervisor Dr. Rajshekar. Thank you.
Next presenter is Divyasri.
Very good afternoon to everyone. I am Dr. Divyasri from Mary Stella College. I am working as assistant tech survey. So now I am going to present about facile efficient synthesis of alpha-NMR using single sulfate gases under aerobic conditions and the synthesis of penta-substituted payloads. Next slide. So alpha-NMR ketones, they are very important intermediates in organic synthesis and also pharmaceutical and medicinal chemistry. And they play an important role as an intermediates, key intermediates in natural and heterocyclic compounds. Traditionally, these alpha-NMR ketones are prepared by the condensation of ketones with the amine followed by the reduction of amine, and also the condensation of ketones and then a reaction with the amines. But these traditional methods have a lot of disadvantages like expensive catalyst, long reaction period, and also they take solvent, they use the solvent also. So growing demand for these simple and efficient eco-chemical synthesis methods. So we have used another catalyst, that is eco-chemical catalyst. We are going to discuss it about later. So this is the alpha-NMR ketone moiety. The blue one is amino part, and the keto part is that is in red part. Next slide. Yeah, we have already discussed the drawbacks of the existing methods. Long reaction time, use of expensive metal-based catalysts, and also low yield side products and toxic and harsh chemical reactions. The main objective of our research is to synthesize a simple and efficient eco-friendly method for the synthesis of alpha-NMR ketones. So, to employ this, we have taken silicosulfuric acid as the catalyst, which is eco-friendly catalyst and also reusable heterogeneous catalyst. To carry out this reaction, under solvent-free conditions we have employed, and also we have achieved high yields and shorter reaction periods and also minimum side products. And the beauty of this methodology is we have extended this work to synthesize pentacitric retinols. So why is this sulfuric acid as taken as catalyst? Because it is eco-friendly heterogeneous catalyst and also reusable, recycled, mild reaction conditions, low cost and easy separation, which is very important for high liquidity leading to excellent yields. So the scheme of the reaction is, so we are taking hydroxyketones and NAD and silicon sulfuric acid as a reason. Then we got these alpha-amino ketones. So these are the optimization conditions. First we are taking Silcazole 400 milligrams under the solid DCP, temperature and reflex temperatures, time on 2 hours. Then we got the yield around 60%. Then same conditions by changing the solid CHDC and then the temperature reflex again 2 hours. Then we got 64% of yield. So then Silcazole 400 milligrams, 50 degrees centigrade, just only temperature change. Then and in 90 minutes, 81, we got 81% of yield. Then the same conditions at room temperature also we have employed, then 75% of the yield obtained. And now I2 iodine as a catalyst, then no, we haven't isolated any product there. Then also under no reagent conditions also, sulfuric acid 400 milligrams at 50 degrees centigrade. Within 30 minutes only we got 90% of yield. And then we have observed temperature effect on the product also. Room temperature also we have read 98% of the yield was obtained. Then same sulfuric acid. So after increasing the time and also using the solvent, we have seen that there is a drop in the yield, like 72%, which means solvent plays negative role on the yield of the product. And also methyl nitrones 75% of the yield obtained. So these are just the derivatives of the alpha-amino ketones. If we just change the NAD derivatives, then we get the alpha-amino ketone derivatives. So these are the derivatives.
Time is over. So I have a question. What is the difference between homogeneous catalyst and heterogeneous catalyst?
So,
Next is
KV Rajita. Please give your presentation immediately. Dr. L. Sivakrishna, please give your presentation here. K. Sai Bhavani. Please give your presentation immediately here.
Good afternoon, respected dignitaries and my dear colleagues. I am Dr. K. Sai Bhavani. I am working as an assistant professor at Government Stella College in Vijayawada. Today I am presenting a paper titled on Biogenic Synthesis of Metal Nanoparticles, a review of advantages over traditional methods. Next slide please. Before going to start my presentation, we all are aware that what are nanoparticles. Nanoparticles are tiny particles with the size of 1 to 100 nanometers, and at the nanoscale level, the nanoparticles are showing excellent features like chemical properties, physical properties, optical So based on this basis, many of the researchers focus on the preparation of nanoparticles by using biosynthetic method. Biosynthetic method means green synthesis method by using different extracts like plant, fruit, roots, leaves, and some algae, bacteria, fungi. So why I am choosing the green synthesis as the best method for preparation of nanoparticles based on the advantages of the we are using here renewable biodegradable resources act as a reducing agent for the preparation of metal nanoparticles. Next slide, please. Next slide. These are the objectives of my paper. To compare green synthesis and traditional methods for the preparation of metal nanoparticles, to demonstrate eco-friendly route for green synthesis, and third objective is to produce metal nanoparticles using natural biodegradable resources. And coming to the fourth objective is we study the physiochemical properties like UV, FTIR, SRD, FTCM, and remaining physiochemical properties for the prepared synthesized metal nanoparticles. And last objective is to explore the synthesized metal nanoparticles for various applications. Next slide, please. This is the synthesis of metal nanoparticles by using traditional methods. We already discussed the traditional methods of other classified into two subcategories. These are the physical methods and chemical methods. Sputtering, plasma method, ball milling method, etc. These are come under the physical methods. And chemical reduction, electrochemical reduction, and irradiation, microwave assisted. These are come under the chemical methods. Next slide. So by using the preparation of nanomaterials, by using these methods, they are having some drawbacks. We already discussed. We are using harmful chemicals and produce toxic waste. These are expensive. It is not eco-friendly method to synthesize, and it is also pollute the environment. Next slide, please. So on this basis, we prepare the nanoparticles by using green synthesis. So this is the biological components for green synthesis. We already discussed. We are preparing the extracts from renewable biodegradable sources like plants, leaves, flowers, etc. and bacteria, fungi, algae. Why I am choosing the green synthetic method for the preparation of nanoparticles is we already discussed the eco-friendly method and easy to process and waste products are also minimized producing. And these are the steps involved in the synthesis of metal nanoparticles by using green synthesis. Step 1, metal salt solution. Step 2, add plant extract. And step 3, biomolecules or reduce metal ions into the nanoparticles. And step 4, these are stabilized by the metal nanoparticles. And step 5, color change indicates the metal ions formation, that is the metal nanoparticles. Next slide. This is the mechanism involved in the green synthesis. Step 1 we already discussed. We are initial phase. We are adding the extract and metal salt solution. Step 2 and
Thank you. What is the principle of green chemistry?
Green chemistry to reduce the pollute. By using traditional methods, we are using harmful chemicals.
How is it related to the
green chemistry is eco-friendly method, sir. So if we are, it is a time-consuming, less energy is required, so no need too much effort.
Dr. L. Shivakrishna, GGU, from GGU.
afternoon to one and all. This is Dr. Shiv Krishna Loke, working as an assistant professor at Godavari Global University. Today I am going to present my work on title called Highly Elusive Boron Complexes, Synthetic Strategy and Salvador Chromosom Properties and Ring Opening Polymerization with related to this boron complexes. Next slide. These are the presentation contents includes introduction and results and discussion, synthesis of acyclic two bases and corresponding metal complexes, and conclusion and future scope. Next slide. So basically most of the work has been done in the case of microcyclic and heteroleptic ligands, but we focus on the type DPM molecules that is called as acyclic molecules. These are the from few previous results which is published by the Jebila group. Next slide. So this is the unique properties of DPM ligands. So one of the properties that promising these can be accessed as promising ancillary ligand system, and these are flexible coordination features, and it have multi-graded coordination behavior. And one of the unique property of this DPM ligands is it undergoes amine azasulfate tautomerization. With this utilizing this DPM ligands, we perform particular applications called as ring opening polymerization studies, and we have done photophysical activities and biological activities, and we also involved to prepare heterodimethyl complexes. So these are the list of DPM ligands I have synthesized the part of this work, and we also conformed a few ligands to conform to the single crystal excited structures. So why have choose only boron? Why not others? Because these boron complexes will access fluorescent probes, and these are fluorescent probes and sensors, and these are the few applications according to these boron complexes. These can be utilized in OLED devices, and these can also as biosensors and it also utilized in the bioimaging and photodynamic therapy. So this is the motivation brings us to do synthesis of this boron complexes with the utilization of DPM ligands. So the combination of DPM ligand with the boron can be called as a modified molecules. These are the promising constants and catalysis, as I discussed in OLED, exactions of biosensors, and these are the applications. Please go to the next slide. So basically we want to prepare DPM related molecules. So for this synthesis we have utilized easily accessible material called pyrrole. When pyrrole is coupled with estophenone, we'll get a DPM molecules. After getting the DPM molecules, simply we have utilized Wills-Mann reaction conditions, so we got the dialdehyde molecule like this. So interestingly we observed in the reaction, so it emits some light. So these molecules emit some light. So after observing this phenomenon, we wanted to do some photophysical properties which are related to these DPM molecules. Next slide. So one of these DPM molecules is conformed with the single crystal exotic structure. Next slide. So these are the absorption, emission, and the lifetime properties of this particular dialdehyde molecule. If you observe the absorption of maximum lambda max will be absorbed in DMSO solvent at 306 nanometers. In emission, we have observed highest emission lambda maximum, that is 497 nanometers in a lithanol solvent. We also performed some lifetime studies of this fluorescence activity. So we got the highest lifetime in estonitride solvent, that is 1.12 into 10 to the power of -8 seconds, -8 nanoseconds. These are the images which we have taken in a liquid phase and solid phase also. Move to the next slide. So these are the another molecule we have focused on. So in the meso position we have changed in previous we have a phenolic and methylene in the meso position, but here we have utilized with double benzene ring. We have yes sir. Move to the next slide. So after with this boron DPM ligands, we have prepared some boron complexes which is conformed to the NMR and B11 and F19 NMR. This is a physical What is the main reason? Sorry.
One more question. Did you prepare all these things at GGU or some other?
No, sir. This is my PhD work, sir. I have recently joined in this GGU. I have completed my PhD at 2024 at Indian University, Guntur, sir. Yes, sir.
Did you prepare all these compounds in Guntur?
Yes, sir. Yes, sir. For analysis, we have depend on some other facilities like IIT or other IIT Hyderabad. So thank you, sir. Thank you for this giving me this opportunity. Thank you, sir.
Next, Ranjita. Ranjita.
Very good afternoon to respected dignitaries, undergraduates and doctorate. Myself, KVB Ranjita, pursuing PhD under the supervision of Professor B. Jagmohan Reddy sir in the Department of Chemistry at Indian University. Today, I would like to present my seminar topic on design, synthesis and anti-cancer activity of imidazole 128 linked with isoxazole supported by molecular docking and ADME properties. These are the contents of my presentation, specific objectives of the work, scope of the work, results and discussions, conclusion, and future scope of the work. Next. So, we are using this topic to produce anti-cancer drug hybrid molecules. That's why we have chosen imidazole single molecule and isoxazole moieties. By combining these two moieties, we want to develop a hybrid compounds which is related to the anti-cancer drug moieties. Why? Because most of the drug moieties in the marketed drugs having anti-cancer drugs. Anti-cancer drug moieties having imidazole 6-member compounds and isoxazole 5-member compounds. Few are shown in the biologically activated drugs, imidazole moieties. Next. In this slide, few of the 5-member isoxazole moieties. So these are the specific objectives of the work. Here we have developed the synthesis of imidazole linked with the isoxazole hybrid moieties. After all those synthesized final compounds, we did the anti-cancer activity biological studies against the two breast cancer cell lines, that is NCF7 and LDA-231. And after did the biological studies, we have done the molecular docking studies and pharmacokinetic properties, that is ADME studies by using this ADME software. Next. So these are the results and discussions of the work. First, we have taken nitroglicerol 2 reactor with the aromatic ketone and under the presence of these conditions, NO600 and THF at 80 degrees centigrade. We got the reactor intermediate 3. Then the reactor intermediate 3, by using these conditions, we got the final product that is 5A to 5O synthesized compound. Next. All these are the synthesized compounds, that is 5A to 5O 15 derivatives. For these, we are showing the one of the compound proton NMR spectra for these compounds. After successfully synthesized all those final compounds, we have done the biological activity studies, that is anti-cancer activities. Among all those compounds, 3 are the active against to the promising we have taken the standard drug erlotinib. It's showing more anti-cancer activities. Here we are presenting the
last slide. Log P and polar surface area. So what is the log P value? Yeah, I think, yeah, here. Then log P, right? 3.34. So what does it indicate? You can check what does it mean, log P, C log P.
I think we have completed all the presentations. Now the session is over. On this slide,
Lunch time, lunch break.
So thank you, sir. Thank you, Krishna, sir, chairing the session. Now we close this session and we'll go for lunch. This is the lunch break. Thank you. And we'll come back within half an hour. We'll come back here after taking lunch. Within half an hour. మీకే చెప్పేది లాస్ట్ లైన్ ఉన్న వాళ్ళందరూ ఫ్రంట్ లైన్ ఆక్యుపై చేయాలి. మీరు ఆక్యుపై చేసి రిక్వెస్ట్ టు ఆక్యుపై ద ఫ్రంట్. Be fast, be fast. I request Professor Nannayan garu, who came all over from Benares University to occupy the dais. Please, sir. Sir, please occupy the dais. Last line of all the round, back on front round. Now I request our student Sirisa to introduce today's speaker to the audience with his biography. Please.
Good afternoon, this is Sirisha from second year MSc Organic Chemistry. To introduce our speaker, I briefly present the biodata highlighting the key points of his background. Professor Kalori V.S. Ramanath, PhD, Professor of Physical Chemistry, Benares Hindu University. Professor Ramanath earned his PhD from IIT Hyderabad in 2005 and has held prestigious international fellowships, including the JSPS Fellowship at QS University 2006 to 2008 and the Alexander O. Humboldt Fellowship at the University of Münster, Germany 2008 to 2011. He has also served as a visiting professor at QS University and the University of Münster. His research expertise spans estimated heterogeneous catalysis, thermosets and thermoplastics, and the biofuels. He has received several notable awards such as the Dr. K.V. Rao Scientific Society Award 2004, Ramanujan Fellowship 2012, and the Fellowship of Andhra Pradesh Academy of Sciences 2021. Currently a professor at BHU since 2020. He has completed 4 major research projects: SCRB, CSIR, DSD, and nano missions. Published sample research papers with holds 5 US patents and has supervised 5 PhD graduates with 7 students currently working under his guidance. I thank Professor Kalori V.S. Ramanath for presenting his research works. Thank you for giving this opportunity.
Thank you, Sirisa. Now I request Professor Nannayan to present the presentation.
Very good afternoon. First of all, I would like to thank organizers for giving me this opportunity to share some of my research in front of you. Yeah, actually it is very difficult to give a talk after lunch break because we are all feeling that we have filled our stomach, right? So that we all feel that sleeping mode. So that very few people listen lecture and most of them are in sleeping mode, right? So I generally prepare a morning session to give the lecture. Okay, anyway, I got an opportunity to give my talk in front of you. I try to make you not to sleep at least. Okay. So my topic of the research is estimated catalysis under heterogeneous conditions. Morning Dr. Krishna is asking one of the audience what is the homogeneous and what is the heterogeneous catalysis. So actually it is not only the separation of the catalyst but also it is having the various advantages over the heterogeneous catalysis. One example I tell you, we have to synthesize ammonia from nitrogen and hydrogen. Without ammonia, we cannot produce many chemicals, right? So ammonia is the basic source of many pharmaceutical and also medicinal chemistry, right? So this ammonia can be synthesized only using the iron oxide as a catalyst. We cannot synthesize by using iron chloride, iron sulfate, or any source of iron or low iron salts or iron salts which is the ligands, desoxyproline or any kind of the pyridine ligands, or it is not possible. It is possible only using on the surface of the iron oxide, which acts as a heterogeneous catalyst to produce the ammonia through the gas process. So that is one of the major advantage and that is the breakdown in the process of the heterogeneous catalysis since last many years. Another important thing is that we know that hydrogenation very well. Hydrogenation on the surface of the ranitidine. So that is also one of the heterogeneous catalytic process, which is used in industry, pharmaceutical industry and others. So it is having not only the advantages of the heterogeneous catalysis, that it can be overcome the problems of the homogeneous catalysis and some reactions which are not able to make it through the homogeneous catalysis, we can make it through the heterogeneous catalysis. That is one of the advantages. Here I would like to discuss about the some what we are going to discuss. So initially first 2-3 slides I discussed what is the enantiomer access, what is the asymmetric catalysis, what is the racemic compound. Although you know most of the chemistry students are present here, maybe you know very well, but I would like to give some brief introduction about what is the enantiomer purity, enantiomer access, how to determine, and what is the asymmetric synthesis, and all these things. So if you go for the fundamentals of the asymmetric catalysis, the racemic compound, the racemic synthesis, that means it is containing 50-50% of the both enantiomers, that is the R enantiomer as well as the S enantiomer. And asymmetric synthesis is the preparation of only one possible enantiomer, which is very important for the pharmaceutical industry as well as the medicinal industry. Today morning we got a lecture from the case from IICT, where we have seen that some of the medicinal plants which are having the chirality, single chirality, and some of them are having the two chiral center, which is the diastereomeric access. And a molecule, of course, it is a chiral molecule. If it is a non-superimposable on its enantiomers, that is, you can call it an enantiomer, so you can see both left and right hand both are enantiomers of what you can see in our regular life. And the resolution, that is a mixture of the compound, mixture of the enantiomers which are separated by various techniques. That is the resolution is the separation of the, if we have the both enantiomers, we can separate R and S enantiomers individually and we can collect it and we can isolate it both compounds. And chiral auxiliaries are, that is the compound where we can add small chiral auxiliaries to a prochiral center mediated reactions. We can get the outcome of the product with a high enantiomer selectivity. That is the meaning of the chiral auxiliaries. So that determination of the enantiomeric access, so that we know many methods by using the optical rotation, by using the NMR method in the case of the diastereomeric access, and also we can calculate either by using the HPLC or HGC. So that is the enantiomeric access, that is equal to enantiomer of one compound minus other compound divided by enantiomer. So that is the calculation of the enantiomer access. So enantiomer access. So next we can go for this next determination of the enantiomer purity. For example, if you take one, if you take from the HPLC, you can see the racemic compound. It is showing the 50-50% or less enantiomers, and in other compound it is showing only high enantiomer access, that is the 95% enantiomer access. So that my topic is what we are doing in our laboratory is the surfactant mediated asymmetric catalysis under heterogeneous conditions. What is a surfactant? Surfactant means it contains both hydrophilic nature and hydrophobic nature in a single compound where one part is highly dispersible in water and another part is highly dispersible in non-polar solvents. So we are, by using the surfactants, we are having in many ways. That is the monosurfactant, Gemini surfactant, and quaternary surfactants. And yeah, this is another important term in the surfactant is the CMC, critical micellar concentration. Critical micellar concentration that is used to determine how much the surfactant is active, how much number of surfactant molecules are required to form the micelle. That is very, very important phenomenon to determine actually what is the role of the surfactant, how it can play a major role in the various applications. So when we go over this next two